All right, I'll go ahead and start.
Let me just introduce.
Sorry.
Just give me 1 second. Hi everyone. So this is batch working group meeting. This is the October 13th. So this meeting is recorded and will be uploaded to YouTube. Just disclaimer, and please adhere to Kubernetes code of conduct. Today we have two topics on our agenda. First, one of them is like Kevin, again from G Research. I think he'll be introducing or presenting his work on interactive jobs using Armada. But before that, I would like to announce or remind everybody of KubeCon. It's coming up, Batch Day on October 24th, which is not next week, the week after that. And so I was also thinking that we could cancel the working group meeting on that week because most of us will be in KubeCon and we'll be meeting there. And I hope also during that meeting as well, you can see like Magic, Diana, and other people from the community. We can discuss the roadmap for the batch working group. If we have like a sketch of the document by that time, it will be a great opportunity to discuss it face to face.
That sounds great.
Okay, so with that out of the way, I'm gonna hand it to Kevin. Kevin, do you want to present?
Sure. It says
Let me give you.
Yeah, please.
Kevin. Make co-host, I guess. Yes.
Okay. All right. So I have a Google Doc that I added to the agenda. So I would say that Armada is kind of an inspiration for this project. So at G Research, we are primarily responsible, or there's a lot of stuff that goes on there, but I work on the open source division. I'm mostly on Armada, which is a multi-cluster Kubernetes scheduler for running batch jobs. And we have a lot of users that like to do different things. And one of the things I found they tend to do is the ability for running Jupyter notebooks onto Armada, and then be able to access the notebook while the job is running in their cluster. And Armada does this kind of they have a pod, a service, and an ingress, and our Armada controller basically starts all of these together, and then the user can use the browser to go to the notebook and then run whatever they want inside their Python code. So I was trying to take a look at what Q is doing, the batch working group, and try to do this using a job, a service, and an ingress. And then I think someone suggested the idea of creating a custom resource definition. And so I have just a little proposal here that I'll briefly walk through, and then I can give a quick demo. This will be a very short talk, but please feel free to ask questions if you have any. In a previous job, I was working at the National Institutes of Health, and one of the popular requests was actually a lot of times with researchers using Jupyter notebooks and also be able to run interactive visualization jobs, or even when I was writing some parallel code, it was nice to be able to get a cluster to run debugging tasks when you need a chance to debug something live. So this was always kind of a common use case I found for how to be able to interactively work with a job rather than just assuming it will finish and looking at logs. And so in general, yeah, the Jupyter popular.
Can you please make the window a bit bigger, just like maximize your document or your browser?
Yeah.
Perfect, thanks.
Okay, yeah. So in general, there's a lot of different use cases in HPC. It's actually like I didn't list a few, but I only listed a few. But I know at NIH, there's they have a huge section about actually accessing Jupyter and how they allow users to do that. And then you can look at some other options here of just like mostly use cases where people do allow users to use Jupyter inside of their research clusters. And yeah, so for Armada, we basically when we submit a quote unquote job, it really is a pod, an ingress, and a service, and it goes to one of our Kubernetes worker clusters. And then the worker cluster is responsible for starting the pod, starting the ingress and the service, and tearing those down once the job is complete. And then usually the ingress is obviously used for exposing a URL to the user. And then yeah, and then once the job is complete, it's removed. All the objects are removed. So really why I'm here is I wanted to talk, I'll give a demo of what I did with the custom resource definition. And then I would like to kind of maybe talk about next steps for integrating with Q if possible, because I'd like to be able to see how this would work with a natural, with the Q as a queuing solution. Yeah, and so I'll just go to the demo, or I'll have a little, yeah, whatever. It's pretty clear. I'll give the demo now. So basically, this is my first time creating a custom resource definition. So this was also a fun little project for me just to understand like Q Builder and how to generate all this stuff, and then walk through some of this. But so what I so my specification for my CRD is a job template. Currently for this demo, I don't really have the ingress one working. I'm using kind, and I find trying to debug ingress and kind is never my favorite. So I'm just going to do port forwarding for now. And so I have a service, and I've already created the interactive job. So you can see I have this Jupyter, and it's actually running a job that is still running, and then the pod is there, and then I have a service. So in general, I'll just port forward. Sorry. So it's pretty I don't have it very clean or nice right now, so it is mostly going to show you the login for Jupyter, and then there's a token that you can read from the logs to get it working. But I just kind of wanted to show that now, like since I'm port forwarding the service and this job is running, I'm able to I have this notebook up and running, and then yeah, basically. What was I else going to say? So the spec is just I have a job template which allows you to run the job, and then for now I just have I hard code it to be a node port service, and it listens on the same port as the container. And then part of the controller responsibility is it starts a job and a service, and then once I remove the Jupyter the interactive job, it removes the other resources. So I can just. So then you can see here, service. Yep, everything was deleted. So I guess this is, I mean, it's a pretty short demo, but so like really my main questions for this group are about like, I guess what I wanted to show this is because I found that with working with research groups, a lot of times batch jobs aren't, a lot of times people do want some kind of networking, especially for like Jupyter. And I noticed that a lot of Q is focused on the job controller. And I wanted to know about if it's possible for integrating something like this into Q and how we could go about that. And that's kind of the question I have. Really about it for this is just talking about like what the steps would be for that. and any questions you have.
I have two questions, but I'll leave it first to the community if there are if there are questions. I'll ask at the end.
I have one.
Diana?
Yeah. So thank you, Kevin, for sharing this. This is really interesting. So it sounds like as part of the requirements is you want to be able to express holistically in some aspect, multiple resources, not just the job, right? So that
Yeah.
all those set of resources can be dispatched or removed from the system holistically. Is that kind of the basic requirement for this workload?
Yeah, pretty much.
Okay. And then also, since these don't really run to completion, which I think of as jobs in the general sense, it's really a standing up of a pod, and then there's explicit removal of these objects in the sense of when you do delete, you want to delete all the objects, but they don't ever run to completion. Is that correct?
Yeah, my thought for that is a timeout on the queuing, either as part of the queue or as part of the job. But then I guess I need to see if the timeout would also delete the CRD completely. So I don't know. I haven't really thought about that, but that's at least kind of what we thought about. Is at least the pod will be it has some kind of active deadline that will terminate after a certain amount.
Got it. Got it. Okay, I got it. Thank you.
Ricardo?
Yeah, so I had a similar question, but I have another one as well, which is you demoed with the notebook, but then actually, because you were talking about ingress, but actually you just did put forward. So in principle, an interactive job should be just like layer 4. It doesn't have to be like HTTP forwarding, right? Like the Jupyter example implies ingress, but for the generic case, we probably are not talking about ingress. It's more something else. Like exposing on layer 4 the port directly, not at the HTTP layer. Is this correct?
Yeah, I mean, in Armada, we do have the ingress stuff working. I'm using Kind, and I always find it troubling to get my ingress stuff working from Kubernetes local.
So it could be like a generic job where you just either get a shell directly on the remote pod somehow using a port. It doesn't have to go through ingress. So I was just thinking also looking forward something like the gateway API where you have both layer 4 and layer 7 possible.
Okay.
It's probably
yeah,
more generic.
Yeah, I know that there will be another talk about that. I don't know much about the gateway API, but I'll take a look at that. Thanks for that. But yeah, I think in general, I would want it to be in like the final solution would be working with an ingress. I just don't know exactly what kind of configuration like I would want for an ingress at this point. So for the demo, I just kind of skipped to that. In Armada, we kind of have we use the name of the port, and then that's the host, or sorry, the name of the pod that creates the host, and then we just have whatever the ingress is in Armada that is what allows the users internally to view the job. That's what is done with Armada, but that would be the final solution, obviously.
Thank you.
Any other questions? So the idea of queuing, and it's mostly centered around resource management, right? And we're talking about hard resources, like things that are, you have limited capacity of like CPU, memory, etc.
Yeah.
Now, exposing a service is not necessarily a hard resource unless we think we have a limited number of IPs that we want to manage. And so in my mind, this is not necessarily something that is going to be the concern of the queuing operator, like whether or not we create a service and expose it. So in a sense, your integration with queue is kind of orthogonal to the requirement that this job, when it starts, it needs to be fronted by a service. So that because you can always create the service from the beginning, it doesn't matter, right? It's not taking up any resources. We're not trying to manage anything related to it. But once the job actually starts, it will become responsive. So that's the only side effect. But creating it beforehand, after the job starts, etc., it's not really the concern of queuing or dynamic quota management. And so it is going to be really the concern of whatever, like, for example, in your case, Jupyter, like let's call it like Jupyter operator that creates the service once the job starts, or maybe even creates it even before, and you have some sort of, I don't know, a ready ping or whatever like that. Okay, once the service becomes responsive, it means that the job was scheduled and now it's serving the request. So that's one thing that I think I would like to clarify. The other thing related to finish. So I guess in a sense, who's going to finish the job? It's the developer or some, right? It's not like say, like I logged out of Jupyter of this session. That means the job has ended. And I'm wondering if Jupyter gives that, like, ability. Basically, okay, I logged off, and so that job should terminate.
Yeah, I think that is something that I've been thinking about, and I posted an issue on Q about having kind of, I guess I'm unclear fully on the nomenclature, but I was wondering for like I'm not as familiar with how this is handled in like an HPC community, but I have seen typically when people have interactive jobs, they have time limits on them, and I don't really. I guess these can be handled by a user creating like the job as an active deadline, but I didn't know if we should have like timeouts as part of a queue, so that like I imagine there'll be like an interactive queue or interactive job queue, which has like a hard deadline of 30 hours, and then that at least forces the jobs to end. Because I do think, yeah, this could be a permanent, if you don't have any kind of time limit, you can have somebody using a GPU for an infinite amount of time for whatever they want to do, which is not a great case for sharing your resources among a group.
Yeah, I mean that's like an interesting requirement. Basically, like and we're like we're discussing preemption in Q, although we'll talk about this in a minute. This can be thought of like as one form of preemption, but there is no new job that's coming to preempt. It's just basically you're getting preempted because of a deadline. So that's an interesting requirement. It's not really related to interactive jobs, right? Like it's a generic requirement around, okay, setting up deadlines around usage. The other thing that you might want to look at is like with job, you can have, you can create index job, but you can also associate it with a headless service, and that would expose, like a predeterministic IP, like a record for each index. And so if you create a one pod job and create a headless service for it, you're going to get like a stable DNS name to that pod, which is going to be the job name -0, which is like the index. So this could be a pattern that you might want to apply.
Okay, I'll take a look at that.
But it's not necessary. Like you can always, if you have your own CRD, then at the end of the day you can do whatever you want, right? Like, but this could be another way of doing this without necessarily having a CRD. Basically, every time you create a job, you just create a headless service for that job, and that's it.
Okay.
But you need to enforce that these jobs are created as index jobs.
Okay.
So this could be like a simpler approach.
And with that, within ingress, would I still need an ingress for that, or would that be?
So, yeah, like from outside the cluster?
Well, yeah.
Yeah, I mean, you need to do, you need to, like, I'm not quite. I don't quite remember if headless services
I think
are
you
only
don't.
internal or not.
You can still expose a service if you would make it like
Yeah.
LB, but I think the main issue with ingress is again that it would imply HTTP, and you probably don't want that because you might want some more generic APIs.
Yeah, and then I guess Ricardo, to your previous point about the logging into a node, I was thinking about that one for a little bit, but I figured it's a little at least it's kind of weird to be able to SSH into a container. I think you have to actually add like SSH capability to the container, and I didn't want to require that you have to modify containers in order to do that, but I guess that is possible. At least that was my.
Yeah, I don't know if it makes sense, but it's a request that we get constantly.
Okay. Yeah, okay.
Also, maybe you want to look at, I just forgot the name now. The ingress is replaced by another API. Not replaced, but there is an alternative API that is kind of newer. Gateway, that's the word, yes.
Okay.
You might want to look into that. But back to queuing, I wanted to mention that since you're using the job API, if you just install queue on your cluster, those embedded jobs will already be queued. So if you're fine having the service and the ingress created from the beginning, then you're already integrated, right? If that's not the desire, then that's where we need extra integration. So basically, you want to have your CRD also have a suspend field. So whenever queue decide that is ready, you can flip that flag. So that's kind of the mechanism.
So you're saying that I mean, so right now, like, you could already create the service and ingress, and then your workload, the job suspended true, and all that would probably work as is. The only issue is cleaning up the job and service after the job is complete, right? Which is a manual process.
Not really. I mean, if you delete the CRD, the job will be deleted, then the workload would be deleted. So that would also work the same way.
Okay.
So it's more about whether you care about the service being created from the beginning. So that would be the difference. Although you could make it so that the CRD doesn't create the service until the job is marked as suspend equals false, which could be your gateway for your control flag for the other two objects. So that's a possibility too. That would be a fairly easy integration. But so that's all good, and that all works when your job is already a fixed size, like you just want one pod throughout the entirety of the interaction. But the question is, what happens when if notebook you can create extra workers or something? I don't know if that's possible. I'm guessing it is possible.
Yeah, I mean, I guess like the idea would be like, for when I think about like with the normal HPC, like you could say I want 4 nodes, and then, or sorry, 4 dedicated computers, and be able to run like an MPI job for debugging purposes within those 4 nodes. So I think that like that would be a requirement down the line for this, is that you would probably want to be able to use more than, I guess I get a little confused with pod and nodes, to be honest. So like, I guess I assume that a pod would be a node in this case. And then, so if you wanted multiple nodes, you probably need multiple pods.
Multiple MPI nodes, yes, usually those would have to be represented as multiple pods. But that's not really a problem for Q if the number of workers is fixed from the beginning. That's not a problem. What is missing is the more like a dynamic scenario where you start with one pod and then you require at some point different number of pods, and then you scale down, scale up, and so forth. That kind of interaction is not defined. There is some people trying to build this into Q, but there are some things missing. So that's where more work might be needed. But
Okay.
fixed size, even if multiple pods, that's already supported.
Okay, I will play around more with seeing if I can just integrate this with Q directly, and then I'll think about more about the service and ingress, like the life cycle for that. But yeah, thanks for everyone for their time. I know Aldo, you
I just
And,
had one
okay.
more question. It was really more for the community, and that is thinking forward. This, I think, the concept of identifying not just the pod creating resources, but other resources in Kubernetes holistically is a powerful concept. And I'm wondering down the road, being able to take advantage of that concept in Q. Do we see this as something we might want to expand on, this kind of requirement where you create, you dispatch a workload, not only the pod creating resources, but also, and not just one pod creating resource, it'd be multiple ones, but also non-pod creating resources. Is that something we might think through, or is powerful enough? And this is an example of a use case where it would be, I'm thinking in user would be nice to have, here's all the objects that I need to represent my job or my workload, and queue it. And then once once it's ready to get dispatched based on, whatever the requirements are, resource demand, then dispatch all the workloads within that.
Are you referring to multiple quote unquote apps, or more than that, like volumes? And
it could be, yes. So it could be multiple resources. And this example, and I'm using this as Kevin's example, is that, these are a few objects in Kubernetes that you think through as one set of resources that represent a job, right? And so obviously other job, yeah. So I'm thinking of it. Go ahead.
Go ahead, sorry.
I was going to say, I'm just thinking of it as right now, Q is queuing the job resource, and I'm wondering, as long term, as we think about queuing and taking this concept of holistically representing not just the one job creating pod object, but multiple resources. If we think that's something that we can, that's a powerful enough to start to, think through what we might do as far as queuing all these objects that represent a job.
Right. So Q doesn't really queue jobs. It queues something called workload, and it's an abstract concept, right? That represents a collection of resources that you have limited capacity of, and you want to subject them to quota. And so whether or not those represent a job, two jobs, a job and a deployment, is really up to the, let's call it the workload controller, right? So So that's what we tried to do with Q. We wanted to decouple these two concepts. Like the workload is not an API that creates resources. It's an API to express how much resources you want.
True.
Right?
That's
It's not
true.
it's not an API that creates pods or deployments or jobs. It's not that. It just tells Q how much resources I want. And then once these resources become available, tell me to start. And when you tell that workload controller to start, it will create them as whatever it wants. And so in that
Right.
sense, what you mentioned is kind of already supported. It's again up to the batch workload controller
Yeah, I see what
to
you're saying.
create things in the way that it wants, right?
Yeah, you're kind of leaving it to the controlling entity to determine how to release, or I don't know what the right term is, but yeah, I
Exactly.
see.
And
And if you were going to include services, you would need that concept as well.
well,
to not
again,
actually,
as I mentioned at the beginning, what is it that you want to control with a service? Is there a resource that is associated with a service that you want to basically control and subject to resource quota? There isn't really. But I mean, it could be that, oh, I don't want to create a service until my job is scheduled, right? So there is not really, you're not really associating with a quota. It's just, okay, once my job is scheduled, which is I want one core for that job, then I will also create the service, right?
exactly.
I mean, I
But
guess, but wouldn't ports and services be considered like constrained if you have like for like Armada, you know, we have a lot of users and we can't have everybody open up a port and not clean up that port. And so eventually you run out of ports to use also if you just let people schedule them whenever. That's
so in Kubernetes, I mean, like IP management happens at a much different layer, right?
okay.
And it is not like a job level resource, really. It's related to the pod. So that's one thing. But yeah, I mean, port forwarding is is I don't think it's an encouraged, like it's a pattern that in general the community encourages, like to do port forwarding on the node. I mean, it has security implications and whatnot. It needs to be like, you need to set up like a proper gateway forwards things to like the backend pod, etc. And I don't know if that's something you want to manage as a resource. It gets too complicated.
Yeah. I guess, yeah, my point is that eventually for a large enough research cluster, I would say ports are something you want to have some control over, because you don't, like, you do want to make sure that they get, once the job is complete, I would say you probably want those ports open again. So that's at least.
But ports at what level, like, are they constrained? They are constrained at the node level, right? But again, like,
I
if you
guess that's true.
have, so it's up to like how many pods you have on the node. It's not a cluster wide resource.
Okay.
But again, like, if you set them up properly using, like, ingress and whatnot, up, like, it's really like a port is associated with the IP or virtual IP that you assign to that service. It's not a limited resource. Ports themselves, all of themselves. Like, it depends on the setup.
Okay. All right. Thank you.
Okay, we've got a few minutes. Aldo, do you wanna quickly talk about preemption or leave it to next time?
Yes, we have a few minutes. It's rather fast. Can I share my screen? I don't have permissions.
You should have now.
Perfect. Thank you. So yes.
Is it just me or Aldo? Are you muted? Yeah, Aldo, you're muted.
Is it the same problem again?
Yeah.
Yes. I'm getting muted once I start sharing. Maybe if I try the entire screen, it works. Oh, let me try that. Share. Yes, can you hear me? Yes? No?
I can hear you.
Yeah, I can hear you.
Okay, thank you. Okay, sharing a tab doesn't work. um, okay, in Q we're working on a proposal for workload preemption. There's basically two scenarios where preemption might be needed. In Q, there is a concept of borrowing quota. So if you set up quota for a cluster queue, and then multiple cluster queues are set up to be in the same cohorts, in the same group, they can share quota when, or rather one cluster queue can borrow quota from another if this other cluster queue is not using the quota. Now, the problem is how to recover that quota. Currently, the only way is to wait for the workloads to finish. And this is clearly not enough for certain use cases. We want to basically end workloads faster. Well, the other use cases within a cluster queue, you could have a high priority job coming in. And even though you're not borrowing quota from other cluster queues, you still might want to preempt a workload with lower priority. So that's the use case. I think it should be relatively common concept across batch schedulers. So, well, the proposal, I was kind of being, I was trying to be as comprehensive as possible, or give users a good amount of knobs to influence preemption. So one kind of knob I was trying to give, and this is based on some discussion that was happening in the issue. If you go to issue 83 for Q, there was some request to be able to favor the preemption of certain workloads based on how long they have been running. Now I came up with a kind of maybe a little bit too complex API that kind of sets a cost curve for the time based on the time, on how good or how bad it is to preempt a workload given how long it's been running. So this is my proposal. I think the most of the feedback I've gotten so far is that it's maybe too much to start. Maybe we can just get rid of it until there is more justification for it. So if you think this is something you might be able to use, let us know. Otherwise, we will park it for now. And the other one is maybe a little bit less, more intuitive. Basically, when your workload wants to needs to preempt some other workloads, just simply say how long it's okay for you to wait for other workloads to finish before you start preemption. So this could be useful if you know you have short running jobs, and then you're okay waiting for this period of time. And so yeah, basically that's the API. I have another proposal over here also to give extra control. What is it, like workload sorting? So how to sort the workloads that are already running to determine which ones are the best ones to preempt. Honestly, I think this is probably an overkill at the moment. So, but I wanted to leave it here so that you more or less understand what's the current proposal for how workloads should be chosen. Like first, sort by lowest priority, then maybe sort by lowest cost as proposed earlier, and then by lowest running time. So yeah, that's the
Aldo, I have a
API.
quick question.
Yeah, I'll just finish real quick.
Okay, sure.
That's the API proposal. I'm still working on the actual algorithm. I hope to have this completed for KubeCon. So if you have a chance to talk with me, we can discuss it, or you can of course submit feedback in this PR already. Yeah, that's it. Yes, Diana.
Oh, sorry, I didn't mean to interrupt you there. I just had a quick question. So I haven't read through this, but do you have the basic concept of expressing whether a workload or is preemptible or not? Meaning that if there's borrowing, you know, and you want your job to run you, and it's not a preemptible or you don't want it preempted, then that allocation of the quota would not be part of the preemptible type of resources that can get reclaimed. So in other words, you know, I say, okay, I want to borrow from my workload. I don't mind if I need to borrow, I borrow, and I know that I have the risk of getting preempted, right? And I can set my parameters for that. The concept
so rather you mean that these workloads shouldn't ever borrow? So
yes,
that's
exactly, right.
That's a good point.
But
There is no switch knob. What the most you
well,
can do is the knob is for the cluster queue rather.
yeah,
Like
exactly.
um, if if the cluster queue is like it's usually has workloads with this kind of requirements, then you can simply disable borrowing for it. And I think these kind of things is better to leave to the administrator. So setting it up in the cluster queue might be a better fit, because if you put in the workload, it might lead to abuse, right? Of course, every workload doesn't
That's true, but it's
um,
true, but I also think it's powerful as well, is that that I know if I submit this job and it gets accepted and with meeting all the policies, that I know it's not going to be preempted. But I have this other job that I don't mind running in the cluster. You know, I'm the same user, I'm using the same quota, but I have this other job that I don't mind it getting preempted. And so being able to express that within the one job adds more flexibility. So I just wanted to know if you're.
I think you can achieve exactly that by setting two cluster queues, where the first cluster queue has the real quota, and the second cluster queue has zero quota, and it can only borrow. So it
Gotcha.
borrows from the existing cluster queue and other cluster queues. So that could be a way to set that up, giving all the control to the administrator instead of the user. Of course, the user has a chance to use one cluster queue or the other.
All right.
So that might be a way, I think. But this brings me to maybe like how to set up best practice. This is an interesting, question. So I think having an answer for this kind of scenario would be good. So that's something we can include in the documentation.
Yeah, that's great.
Yes, I think I had a parallel thought while you were talking about this, but I forgot. Um, any other question, or did you have a second question?
No, I
No.
didn't.
Okay.
But thank you. No, I actually do have more questions, but I'll just make more comments in the because I need to think through it, and I also want to read through it before I ask the question. So
Yes, we're kind of trying to give some control in the workload, but at the same time we prefer to put most of the control in the cluster queue. because it leads to less abuse from end users.
I have a question in the chat.
Oh, thank you. How to manage preemption among non-borrowing cluster queues? Are all jobs considered to be scheduled after the previous one completes? I guess this relates to higher priority jobs. I'm not sure I understand the question. Can you reword
Yeah.
or ask live?
Yeah, sure. I mean, I was just, taking a point on what we just discussed, is that there are two queues, one can borrow and one cannot borrow, but you have like n jobs queued in a cluster queue that um, that that cannot borrow, right? I mean, meaning all the jobs should complete first. So, like, how do you prioritize it in that scenario?
Right, for now, there is a knob for priority. The workload can have priority. But otherwise, it's mostly FIFO, first in, first out.
Okay, got it.
Yes. There is somebody working, I don't know if Kant is here or Alex. I don't remember. Sorry, I don't remember which one of you were working on a proposal for giving more knobs for sorting within a cluster queue. So yeah, because today we only have FIFO, kind of a strict FIFO, which is FIFO all the time, or some FIFO where if it doesn't fit, it still tries to schedule other workloads. But there was an idea of expanding these knobs to more sorting mechanisms, but that's still ongoing.
Okay, thank you.
All right, we are 5 minutes over time. Thank you, everybody, and hope to see most of you in KubeCon in 2 weeks. Just as a reminder, I think we'll be canceling the working group meeting on that week. I'll send an email and post a message on the Slack channel as well. Thanks.
Okay, great. Thank you.
All right, bye-bye.